Good morning to all. Today we saw fluid mechanics and machinery. So it's coming under third year mechanical, second year mechanical, third semester. So subject name is fluid mechanics and machinery. So first of all, we must know about what is meant by fluid. Fluid is nothing but a substance that deforms continuously without any action of shear stress. So fluid is having no shape at all. So the spring itself, we must know three types of fluid is there. One is liquids, another one is gas, another one is combined with both of liquid state of gaseous state. So first of all, we must know about the definition of fluid mechanics. So fluid mechanics is nothing but it's a subject which deals with the behavior of fluid under the action of force or rest condition. So the application of fluid mechanics is we are on day-to-day life. We are seeing the motion of fish under the water. So controlled by the law of fluid mechanics, as well as the circulation of blood in veins and particles. And the water supply system and oil pipelines are designed in the fluid mechanics. So next slide is properties of fluid. So main properties of fluid is density. Density is nothing but the ratio between mass by volume. So mass is nothing but the weight of the fluid. So volume is nothing but the occupied fluid under the some vessels or anything else. So formula is rho is equal to mass by volume. So unit is, so density is nothing but kilogram per meter cube. Mass coming under kilogram. Volume is nothing but meter cube. So second thing is specific volume. So specific volume of the fluid is defined as the ratio between volume by mass, as well as, so another definition is reciprocal of density. So it's nothing but volume divided by mass. Unit is meter cube per kilogram. So third one is specific weight or weight density. So it's nothing but defined as weight per volume. So weight defined as mass into acceleration due to gravity. So weight is equal to W is equal to M into G divided by volume. So finally, weight, specific weight W is equal to rho into G. Unit is Newton. So fourth one is specific gravity. So specific gravity is nothing but defined as a ratio between density of the fluid to the density of standard fluid. So some unknown fluid is given means how we will find out the specific gravity of a particular liquid is nothing but S is equal to specific weight of given liquid. So consider for say example any petrol or kerosene, anything unknown fluid, density of fluid, how to find out is, so specific gravity is equal to mass density of fluid divided by mass density. Standard fluid is nothing but water. So density of standard fluid is 1000 kilogram per meter cube. So unit is unknown. Unit is no unit. So density of fluid is kilogram per meter cube divided by density of standard fluid kilogram per meter cube. So divided, both divide, we conclude is unit is less. So next topic is beyond the properties of fluid, basic four properties. We find out solve out one problem. So problem is calculate the specific weight and specific mass and specific volume of liquid having a volume of 6 meter cube and a weight of 44 kilonewton. So given data is, volume of the liquid is given, so V is equal to 6 meter cube and weight is 44 kilonewton, that is nothing but 44 into 10 power 3 Newton. So specific weight already seen previous slide. Specific weight W is equal to weight per volume. that is nothing but W divided by V. W is already given 44 into 10 power 3. Volume is nothing but 6. So if I solve it, we are getting the result 7.33 into 10 power 3 Newton per meter cube. Next, specific volume, that is rho is equal to mass by volume. So mass is equal to M divided by V. W is equal to rho into G. Already we find out the W value, the 7.33 into 10 power 3. That is equal to rho. Rho is nothing but rho is, we have to find out, into G is nothing but acceleration due to gravity 9.81. So divided both things, we get a density value. Density rho is equal to 747.53 kilogram per meter cube. So third find out is specific volumes. Specific volume is nothing but already the definition itself we says reciprocal of density. So already we find out the previous step density value. We divided by density, we are getting 1.337 into 10 power minus 3 meter cube per kilogram. So second problem is same things. So we skip on the next topic is viscosity. So viscosity is a main property of fluid. So the property of which a fluid offers resistance to flow. So for say example, density of our petrol is depend upon the viscosity. Okay. So under the action of shear force. So fluid offered to flow under the action of shear force. So that is called as viscosity. Viscosity defined as two terms. One is dynamic viscosity, another one is kinematic viscosity. So this is our Newton law of viscosity. The Newton law of viscosity is nothing but the applied shear stress on a particular plate is directly proportional to the rate of change of shear strain. So rate of change of shear strain is nothing but du by dy. So we equal the equation. So tau is equal to, we have to eliminate the proportional to constant tau is, so tau is equal to mu into du by dy. So tau is nothing but shear stress, mu is nothing but dynamic viscosity, du divided by dy is nothing but shear strain. So we are applying the formulas. So mu is equal to tau divided by du by dy. So tau is nothing but shear stress. Stress is nothing but load per area divided by, so velocity gradient or rate of change of shear strength, that is nothing but change in velocity divided by change in distance. So finally we got the mu formula. Mu unit is Newton second per meter square. CGS unit is we centrally we are get the data is in terms of poise. 1 poise equal to 1 divided by 10 Newton second per meter square. So formula itself they are giving centipoise also. So 1 centipoise equal to 1 divided by 100 poise. So second thing is I already classified two types of viscosity is there. One is kinematic viscosity, another one is dynamic viscosity. Dynamic viscosity already we said mu. Second thing, kinematic viscosity is nothing but ratio between dynamic viscosity divided by density. So that is mu is equal to mu is equal to mu divided by rho. Mu is nothing but dynamic viscosity. Rho is nothing but density of the fluid. SI unit of kinematic viscosity is meter square per second. So CGS is nothing but centigram seconds. So it's another one type of unit system. So that unit is coming under for kinematic viscosity is stroke. So one stroke is nothing but 10 power minus 4 meter square per second. Okay, thank you.